This video is going to be our lesson on symbolic differentiation. We've done some of this as we've gone during problems. So this is basically using tables or something where we've got just points listed and then we're supposed to give information based on that. So very common that we have a table question, or maybe we have, like, one of them will be that we have graphs but we don't actually have the formulas for them. So it's very common to be on one of the free response questions. Okay, so let's start with this first one. So this table gives the values of a function. It's differentiable, which is important, on the interval from 0 to 1. Find f prime of 0.1. So to find f prime of 0.1, that means I would have to find the instantaneous rate of change, which of course I can't do because I don't have the functions here. So the best I can do is approximate it by using the values that are close to it on this graph. So normally we would go around it, but here I can't really go around it, but I can go from 0.1 to 0.2. So remember, our notation is important, so I'm going to say that I'm doing f of 0.2 minus f of 0.1 over 0.2 minus 0.1. And then after that, I can just put it in the calculator and get the answer. So you don't need to write further, and the answer there is going to be 1.72. And so that would be my estimate for f prime. All right, so let's go to another example with a table that's going to ask a lot of things. So here we have this table of values, and they've given us x for 2, 3, and 4, and f of x, f prime, g, and g prime. So they gave us all those values. And then they're asking us to find various things. So we want to find the derivatives for each of the things given. So A says capital H of x, so that means I'm wanting to find capital H prime of x. So I need to do that. I'm going to do this symbolically with what I have. So the H is defined to be f of g of x, so of course that's just going to be f prime, leave the inside alone, times the derivative of the inside. And now what I want to do is find, it says find all of these following at, oh, and I guess it's not on here, but anyway, at x equals 2. So we're going to get the answers for everything at x equals 2. So that means what I want to find is h prime of 2 now, which is going to be f prime of g of 2 times g prime of 2. So f prime of g of 2, we'll have to look at the table. So I need to do f prime of g of 2. So I'm looking at g of x, and x equals 2. So I get 3 for that, times g prime at 2. So now I need to look in this column. G prime at 2 would be -1. Now I'm doing f prime of 3. So now I need to look at 3 and look at f prime. Okay, so then that's going to give me -2 times -1, so I get an answer of 2. So that's the answer for h prime of 2. Okay, and then B here, I need to do k prime of x. So I need to do the outside function here is cubing something. So I'm going to do my power in front, leave the inside alone, lower the power by 1, times the derivative of the inside, because of course this is not exactly plain x. So I have to do the chain rule. So I want to do k prime at 2, so that means I'm going to plug in. So I'm going to have 3 times f of 2 squared times f prime of 2. So that's 3 times. So now going back and looking at our table, f of 2 equals -4. So this will be -4 squared, and f prime of 2, again, back to our table, f prime is the, look in that column, f prime of 2 is 8. So I write that in, So I get 3 times 16 times 8. And if I do all of my arithmetic, it's 384. Remember, if this was a free response question, I would actually literally stop right there. Just make sure you have parentheses for squaring that -4, because it does not mean the same thing without those. So just don't forget on free response, don't do all that extra work. Okay, so now we have C. So we're going to do P of x, which is f of x times g of 2x. So P prime, actually let me write down here, P prime of x. So key important thing here is this is a product. So I have to do the product rule. So I have first times the derivative of the second. So g prime of 2x and then times 2 because the inside again is not plain x. So that's first times derivative of the second plus the second times the derivative of the first, which of course is just f prime of x. Now I need to figure out what p prime of 2 is going to equal. So that's f of 2 times g prime of 4, because it's g prime of 2x, and then that whole answer times 2, plus g of 4, because it's 2 times 2, times f prime of 2. So it's always helpful to write that stuff out and then go through and then find the table values so you don't end up messing up doing too many things at once. So f of 2 is -4 times g prime of 4. So looking at my table again, g prime of 4, so my answer is 3, times 2, because that's this 2, plus g of 4, which is 2 times f prime at 2, again looking at your table, that's 8. And so again, if this was a free response question, I definitely would stop there because that's done. But if you're trying to match on multiple choice, you're going to need to do your arithmetic. So we have on the left, we have -24 plus 16, so that makes -8. Okay, so let's do one more on this table, and then we'll look at doing it with a graph. So again, I'm doing r prime. Difference here is this is a quotient. So now I'm going to use the quotient rule. So I have bottom times the derivative of the top. So the derivative of the top, it's f prime of whatever's inside times the derivative of the inside, because the inside is not this plain variable x. Okay, minus the top times the derivative of the bottom, all over the bottom squared. And be sure you put that entire expression in parentheses, because it doesn't mean the same thing to write g of x squared as it does to write g of x whole thing squared. Okay, now I'm going to show that what I'm doing is plugging in 2. So I write r prime of 2, and I just start filling stuff in. So I'll have g of 2 f prime of 4 times 2 minus f of 4 g prime of 2 all over g of 2 whole thing squared. And then I'm just going to fill in all the numbers that I have. So g of 2, so g of x is the second to last column there. So g of 2 is 3, f prime of 4, so that's the column under f prime, go down to 4, I get -1, and then times the 2 that's already there, minus f of 4. F of 4 is 0, so I could go further, or I could also stop because it won't matter. It's going to be 0 times something, but I would just go ahead and write it in. And that way when you look back, like if you're trying to check answers and stuff too, you also see everything that you did, so you don't wonder why you didn't write that. And then on the bottom, it's g of 2 and g of 2 is 3, so you'll have 3 squared. Again, for a response question, done. Not for a response, I have to figure it out, so I'm just going to have negative 6 over 9 or negative 2/3. Okay, so that's how we do that. So now let's look at example 3, or example 4, sorry. I guess on here it says example 4, in your paper I think it says example 3, whatever. So this example with the table. So the difference here is we're still going to have h of x equal f of g of x. So f of x is the sort of pointy graph that's segments, and g of x is the curve. And then I'm going to find all these different derivatives by using this graph, okay? So what I'm going to actually do here is I'm going to use this segment that was here a second ago. Here it is. I'm going to copy this and I'm going to put it on my other pages because what I'm going to do is use that the same way you would use like a protractor to estimate things. And I actually thought I already did this, but I guess I didn't, so I'll just keep copying it. And you can also change the color. So for me, this is what I'm going to do, but you will just have a protractor, so you just need to do, you just use a protractor and lay it there and draw lines. So first thing is g prime of 3. So I need to go on the graph of g, and I need to go where we have 3. G, remember, is the curvy one, so I'm going here to 3. So obviously my line needs to turn, and then I'm going to set it here at 3, as close as I can get to a nice tangent line. That actually looks pretty good. Okay, so I've got my tangent line drawn there. Pretty good right there at x equals 3. So I'm supposed to estimate g prime of 3. Well, the estimate of g prime of 3, so again, it's an estimate, so put approximately, is going to be the slope of that line. Well, where I've drawn it appears to go through the point 3, 5, because that's the point that is at g of 3. So 3, 5, and then it also looks like my line goes through 5, 4. So I'm going to use those 2 points to get my estimate of the slope of my line, which would be the value of that derivative there. So I'm estimating, but I'm going to have 5 minus 4 over 3 minus 5, which is negative 1/2. So that is what I believe g prime of 3 to be, or is my estimate of it, okay? So now let's go to b. So on b, I'm supposed to do f prime of g of 3. So this means do f prime of g of 3. Well, we know that g of 3 is 5 because we just went through that on this graph. That point where that tangent line is right here is 3, 5. So we know this is f prime of 5. Now we need to go look at our graph of f at 5 and see what we want to say here. So right there, we want to know what's the estimate of the derivative. Well, my answer is that this is that f prime of 5 does not exist. And the reason is it's because of the corner, but don't forget we can't use that as a reason. So the derivative from left and right of 5 are not the same. Okay, that's probably a good explanation. Really should have to do with limits, but technically it doesn't exist because the derivative from the right is going to be whatever the slope of that line is. Derivative from the left is the other one, so they're not the same, so therefore that limit does not exist, okay? Or that derivative does not exist. All right, let's do h prime of 3. So h is defined to be, it's written at the beginning, h is equal to f of g of x. Okay, that's at the beginning of the question. Tells you that that's what h is. So to do h prime of 3, I need to do f prime of g of 3 times the derivative at 3. Now that's a different way to do what we were doing earlier. You could also do h prime of x and write that down and then plug in 3, or you can just go straight to h prime of 3 as long as you follow the derivative rules, okay? So it's kind of what's up to you. So that means I'm going to have f prime at g of 3, and remember g of 3 is 5, we've been doing that, times g prime of 3. I just found g prime of 3 in the first problem. That was negative 1/2. But f prime of 5, I also just found that this does not exist. So therefore, h prime of 3 does not exist. Okay, because f prime of 5 does not exist, because I already found that in the last problem. Okay, so that would be my answer there. F prime of 7 would be to just simply do the slope there. So let's go look at where that would be. So if we're on the graph of f, remember the pointy one, if I'm at 7, I'm right here. So if I'm right there, all I need to do the derivative is find the slope. So it looks like this point and that point would be good points to use. So that would be 5, 6, and 7, 5. And I could use those points to get my slope. And I would find that f prime of 7 is going to equal 6 minus 5 over 5 minus 7, which is negative 1/2. Okay, so I get a slope of negative 1/2 there. And then E says to do g prime of f of 7. So we're going to have to figure out what f of 7 is. F of 7 means literally the point on the graph. The point on the graph at 7 is 5. Okay, so that's f of 7. So that means we're doing g prime of 5. And now we have to go on the graph of g and approximate the value of g prime of 5. So there's where we need that line again. Okay, so I'm going to use that line, and I'm going to go to 5 on G. Remember, G is the curvy one. So right there, and then I'm going to obviously have to change my slants of my line. So you can use, again, a protractor and go to where 5 is and draw the best possible, do the best you can to draw a tangent line there at 5. Okay, so there's my tangent line at 5. It appears to be the point 5, say, it looks like G is at 5, comma, 3 points. And it looks like about 3.5. It looks pretty much right in the middle right here. It looks like that lines up to that. So it looks like that's a good point, 5, comma, 3.5. And then another point that we have would be right here I could use for my line, which is 7, 2. So I can use those 2 points to use for finding my approximate value. So what I need to do is say that g prime of 5 is approximately, or actually I can just do it right here so I tie it all together. So this is approximately the slope that you get here, which would be 3.5 minus 2 over 5 minus 7. 3.5 minus 2 is 1.5 over negative 2, so half of 1.5 would be negative 0.75 or negative 3/4. And that should be about what you get. Depends on how you, again, lined up your line. So last one, and then this will be it for this video, is h prime of 7. So again, h prime of 7 would be, h was defined to be, so remembering that h of x is f of g of x. So h prime of 7 would be f prime of g of 7 times g prime of 7. Again, if you want to, you can do h prime of x equals f prime of g of x times g prime of x, and then fill in 7, and then write h prime of 7 like we did at the beginning. Either way is fine. So now we have to do f prime of g of 7. So we have to look at 7. At 7, we're at 2, so that's f prime of 2. If I look at g of 7, oh no, g of 7, not our value, sorry, g of 7, so let's look at that. G of 7 is right here, so we can call that about 2.8 or so. So g of 7 is about 2.8 times g prime of 7. Well, g prime of 7 will have to do some sort of estimate using, again, the tangent line. So let's take our line and we'll move it so that it's tangent at that green point that I marked at 7. So that's about right there. So it looks like I can use that point. So for that one, I can use 7, comma, about 2.8. And the other point that looks good is 8, 3. Right here. So I can use these 2 points to write my estimate. So I'm going to get 3 minus 2.8 over 8 minus 7 as my approximate value of g prime. So now we can keep going. F prime at 2.8. So here I need to actually change this to approximately because I don't know this value I'm estimating, and I'm kind of estimating the 2.8 also. So f prime at 2.8. So if we go to 2.8-ish, so let me use red. If I'm about 2.8, that's about right here, and we want to be on f, and we want the derivative there though. Now the derivative there will be easy because that's a line. So I can just get my value of my slope there, which you can look right on the graph and see that it's -2. So this is -2. And then this is about 0.2 over 1. So it's about 0.2. So my answer is about -0.4. And everybody's can be a little different because, again, we're estimating. So as long as I'm showing what I'm using and things work, then that's good enough for an estimate. So that's it for doing differentiation symbolically from tables.